Hello, welcome to episode 17 of our live stream where we're making an NES game live on Twitch. And at this point, from the last episode, we had worked on exporting our project out to the game, generating assembly code and generating these files that handle the drawing of the entities based on filling out the sprites in the hardware. So the idea was that based on the content in the asset tool, so if we look at like this blaster sprite, it is generating two hardware sprites for the 8x8 based on the size of the content, and then generating this assembly to do the drawing of the sprite in the code. So we had replaced some code that was essentially hard coding the entities that we were drawing. What is that called? Drawentities.inc. And by doing that, we eliminated the need to have that code here in the main game within the VBlank. The only thing, though, is as I was thinking about this over the weekend, I was trying to debate if it really made sense to have this be something that we are generating code for. And there are a couple of reasons for that. One is I'm not sure that the performance gain of doing this is potentially worth the complexity of then having to manage all of these entities. So what I mean by that is we've run into a couple of times when we were coding stuff up that the more code you have between your branch statement and the actual branch, the more likely it is that you're going to eventually get a range error where then you have to start rewriting your code to handle that problem. Whereas if we were to generate the sprites and use the hardware sprites based on the based on some data instead of generating assembly, the code would be probably more compact, and then we wouldn't have to worry about, are we eventually going to run into a situation where we can't do the branches anymore. So like, I'm not worried about the jump, because the jump is able to reference I believe a 16-bit offset, but the branch if equal and branch if not equal, they use an 8-bit offset, and pretty quickly you run into a problem where it can't branch. So although we did spend a good amount of time working on the code to move this out of here, it might be better that we don't do that. So it's one of those things where, I don't know. For me, when I'm working on something, I tend to. Well, let me go back. What I used to do is I used to kind of agonize over, like, oh, should I write it one way or another? And the problem with that is that you can spend days agonizing over it and try to figure out what the best solution is. And sometimes you don't actually have all the information you need to make that decision because you haven't done it yet. And especially if it's something brand new that you haven't ever done, not only for the project you're working on, but just in general, you don't really have a good understanding of what it is that you're trying to do. So sometimes it's better to just write the code, see how it turns out, and then sometimes you have to rewrite it. It happens. It's not the end of the world. And better to rewrite some of the code that you've written now, early on, versus actually getting stuck with something that's not going to work well. So one caveat to that is I do want to do some testing to see how long the VBlank lasts for with this code versus what we rewrite. And as part of that, I also want to make sure that we're that I can revert back if it turns out to be terrible, right? Like if the performance of this method is drastically better than the version where we we don't auto-generate the assembly, then I'll want to go back. So this is an area where source control is super helpful, because I can make this change. I can even make this change in a branch if I'm not sure that I'll get rid of it, and come back to it another time to re-examine it or retest it. So what I want to do is I want to make sure, first of all, that I've got this code all checked in, which I believe I do. So that's committed. The other stuff that's here that's not tracked, I don't care about, because that's auto-generated code. What I do want to do, though, is the asset tool, we haven't put it into any sort of repository yet, so this is a good point to do that, even though actually we probably should have done it sooner. Actually, maybe Visual Studio, because I know Visual Studio has an integration with Git now. Let me see. Is it in a repo here? So to start a program, where is that? Source control. Okay, so it actually has the source control. Looks like it's got the source control already set up for me. I'm pretty sure that was the option that I chose anyway, which is good. That's, yeah, okay, cool. So let me do this. I am way more comfortable in source tree than in, oh, I don't want to add a new, I didn't want to do that. I'm way more comfortable in source tree than I am in using Visual Studio's built-in integration. So I'm just going to open it up in that. Is this it? Is that going to work? Add? Yeah. Okay, cool. So let's commit all of these files. Let's commit all these changes. I mean, we've done a lot of stuff. Some of the stuff is not necessary to commit because it's not relevant to the project. It's content that we don't want to put in Git. Git generally is not great with binary files, so we just want to kind of stick to text stuff. So that we want to stage that. I don't know what that text document is, but I don't think we need to stage it. We do want to stage Tiger because we've made changes to it to enhance some of the functionalities specifically for what we're doing on the NES. And there's our GUI stuff. So let's stage those selected items. So we're adding that. Asset tool can export sprites and projects, although still missing tile, dedupe, and palette management. Oh, also tile mapping. I mean, there's a lot of stuff we're missing, but that's okay. So let's commit those changes. All right, all of that is in there. Let me just make sure I didn't miss anything. I just want to make sure that, like I said, we can go back and revert any changes. So like if I, let's see, if I save that change, it should, yep, it picks up on it immediately. Okay, great. So that's good. So, because we're going to basically make a pretty major change to this, and like I said, I want to make sure that we're not messing anything up. So what I want to do is I want to load, I have that Lua script that I had written, and that's timing the vblank based on, if we open it up, where are you trying to open it in? Sublime text, thanks. So yeah, so basically all it's doing is it's registering that if this location in memory is written, it's looking for just the one byte that was written there, and if it's the value 2, it gets cycles, and if it's value 1, it gets cycles, and then takes the diff and writes it out to the screen. So pretty basic, but it's gonna help us calculate how long our vblank is taking, because if you look at the actual vblank code, the first thing we do after pushing A is we load A with 2 and we write to 7FF. I'm pretty sure we're not doing that 7F. Yeah, we're not doing that 7FF anywhere else, which is good. And then when we're done with the PPU, we load A, and then we write to 7FF again, and then we don't time these things, but that's okay. I mean, in the grand scheme of things, it's a few cycles, and I'm not super concerned about that. That's not the part that's going to be a problem. So once we start the loop here, you can see, you know, we've got, depending on how many things are happening on the screen, anywhere between 1300-ish and 1800-ish cycles. And I believe the NES VBlank, the time before VBlank starts drawing again is somewhere in the neighborhood of, I want to say 2700 cycles. We can even double check that just to make sure. NES VBlank cycles, yeah. So 2273 about. So this person's saying 2387. Let's figure 2200, right? Which we're getting awfully close to, surprisingly. I mean, I really haven't done any optimization or anything. This is all just kind of going from the perspective of what can we do and how do we do it. We'll have to eventually be a little bit more careful with how we're processing things, but let's see how this change impacts things. I mean, if we look at if we look at our baseline of just the game scrolling, you know, around 1342 cycles. When we make this change, if we see that number go up, we know probably this was a bad idea. All right, so include draw entities. So we're going to change this. So instead of it being us including this, what we really want to do, or what I want to try to do, is I want to try to make the project export the data related to the sprites in a way that we can track, we can count down how many sprites we have to store in what position in memory. The sprite memory part, that's easy to do because if you look at that, we're just incrementing, or we're just using, yeah, we're incrementing Y and we're storing it in sprite mem. So as long as we're not using Y for that, we're good. We're using X for indexing into our entity. So we may have to play around with that a little bit. But so what we can do here is, well, we can start with, I guess, the same first few lines because that's not going to be any different. And I do still want this to be in its own scope so that it doesn't interfere with anything else. And this initialization is the same because we're still doing our initialization like we were before. This store A on 7FE is for debugging purposes. If you remember from some of the last streams, what I was doing was setting a breakpoint on writing to that memory address. That was a recommendation from someone on the YouTube comments. The name escapes me now, but it was a good one, and it certainly helps debugging a lot because it makes it easier to set your breakpoints rather than what I was doing with setting the no ops in the code. Certainly, you know, that worked, and I was able to find my code that way, but this is a lot quicker. All right, so you know, we don't actually have to do that every time. I don't want to mess with that right now, but we don't have to do that every time technically, because we're not changing sprite mem. If we were changing sprite mem, we would have to. So put that in there just as a note to myself in the future. so that future Mike doesn't screw that up. All right, so we have temp. We can use. We have some variables that maybe we don't necessarily need, but I'm good with. So we have temp. We'll probably want to use that for our sprite counter. So let's see. So we're going to need to know. We're going to need to know how many sprites we want to draw, right? Because we want to draw potentially more than one sprite. So we're going to have to increment something that references the memory location where our, let's see, where the tile information is. Although, if the tile information isn't changing when we create the entity in memory, maybe we can load that in so we don't have to keep reloading. The only challenge with that is that then we have to have an array of the tiles that's variable based on the number of tiles for the sprite, and then we have to store that information for every version of the yeah, that's not going to work. I think it's going to be better to look up the tile in a global table of tiles versus storing that in every entity. I don't know, that's some other thing we can optimize. So, I mean, the Y position and the X position is pretty straightforward. The part that's not as straightforward is the offsets. So, just talking about it generally, we have the tile information, or the tile index, right? We have the sprite offset for the X and the Y. I think we'll probably have those be two separate things. Right, so we'll have the tile index be one thing, for organizing it like this. So if the tile is 0, then the X index offset would be 0, the Y offset would be 0, and then you'd say, okay, for the next tile, which is 1, the X offset would be 8, and the Y offset would be 0, right, and so on and so forth, where we're building an array of values that allow us to compose that sprite. And that's relatively straightforward, I guess. So let's see, what would I guess the other thing we would need to do is we would need to have a sprite count, or a sprite tile count, I would say. I mean, and would that be a separate table? How would we reference that in here? So I guess it would be based on the entity type. We'd have just a table. So I'm thinking what we'll do is we'll have a label called entities, or entities, right? And that's going to have however many tiles are necessary. And then based on that, the entity info will correspond in length. The only thing with that is, how do you look up into that? I don't want to have to do a summation of all of these to index into it properly. Well, let's get the first part working. So the first part of this would be that the asset tool is going to change how it's generating data, and instead of writing code, it's going to, you can just delete all of that. It's a good thing about having it in source control is I can always get it back. All right, so we've got our header. well, actually, I probably want some of the information that's in there. Maybe some of the data. So I don't care about this. Let's see, what is this doing? This is the comparison operations. We don't care about that. What we do care about is I want to make the label entities, like I said, right? And then for each of those, I want to figure out how many total sprites. So let's see. I don't think I need this stuff right now. I do need it to, well, I do need it to export the sprite still. So I can get rid of the printf because we don't need to do that. Okay. So now I've got the total sprites, and then what I can do is I can output that to that entity section. Would that just be a binary file that we would append that data to? I guess so. Sorry, so I'm like figuring this out. I haven't fully thought through exactly how this is all piecing together. One of the many joys of doing this live on stream. I do want this to be... I do want that to be just a binary file. And then, let me think about this. So this is just doing, okay. So we'll say tile count data equals -1. That's open S tile count data. Oh, what are the crazy flags that Microsoft needs for this? Where is that export? I'm just going to copy these because they're basically what I want. Okay. And then obviously I need to similarly close that. I probably can close it earlier on, but tile count data. But I'm not sure. We'll see how this all kind of pans out. So, all right, I've got my total number of sprites, so I want to write that to tile count data. Excuse me. And I want that to be character because I only want it to be 1 byte that we're writing out, and then we don't need that. And then this is going to be our X and Y data. Now, do I want that for every? Part of me wants to just include this as binary data in a separate file, but then examining this is potentially harder to do without a hex editor. Not that that's a big deal, but the X and Y data, I would want that to be viewable together with the actual tile data that we're writing out, which is what we're doing here, because potentially if I have to debug anything, I want to see, like if I want to debug something that this is doing or something in the game, I would want to be able to see the values in the source directly. Which means that probably I should just, all right, let's reverse that for a second. It's going to make the code a little bit bigger, but it's also going to make my life potentially easier by making it, oh, well, it's going to make my life easier in the code, but it's going to make it harder to write this out because of the way that we're writing this out. All right. Because I want to do this for every sprite first, and then I want to do the X and Y data. Boo. That's gross. Should I write this to a buffer and then write that all out to the file when I'm done? That would make it a lot easier. I could just concatenate the strings on. Sure, let's do that. Tile count buffer. Yeah, I know I don't have max buffer size defined anywhere. I don't know, 4K maybe? All right, so I got my file, I've got my total sprite count, so what I want to do is, what's the syntax? I don't remember the syntax here. Byte. So I actually need to tile count buffer tab dot byte space. I think this is going to complain because I'm using regular string cat instead of string cat s. Okay. Yeah. Okay. All right, good. So I have that, and then I'm going to total number, and I need a buffer to convert that for me. I have that temp already, which doesn't need to. This is just a little temporary buffer for doing the formatting to a string for me, so I don't have to do anything crazy to make this work. So I want this to be hex, and then what is it? It's just $hex. And formatting temp. Oh wait, this needs to be max buffer size. So I'm concatenating that, and then if so, yeah. So if we're not at the last item, we gotta add a comma, right? Oh wait, that's for each one, but only if it's a sprite. We don't want to do that. Sorry. Right? Did I do that right? Yeah. If why is that? Oh, okay, because that's in that loop. All right. So if I doesn't equal current item count, then string cat s to tile size buffer or tile count buffer, a comma and a space. We need max buffer size. All right, so we're concatenating our commas. What is this? Placeholders. What's the problem? That's because it needs truncate there. Yeah. All right. Was missing an argument. All right. So I've got that. I've got my code generating the tile counts. Don't need to do this. I don't need the end scope anymore here. And then I do want to set up the tile count buffer here. Oops. Do it this way. So that built, and then we don't want it to be doing this. Similarly to the tile counts, what we want to do is we want to essentially add that to a buffer where we have our tile x offset and y offset, and then we're going to just kind of write everything out all at the end. In fact, this part where I write the entities and the byte stuff, I can actually do that down here, which makes more sense because of, oops, what did you just do? Visual Studio. I guess it was still scrolling because it's closer to where we actually will be writing this content. All right, so that's good, and we need a new line at the end. So let's just make sure that this is all working as expected. Oh, except that I just noticed that there's no, oh, it's, okay. No, that's fine, because it doesn't need the space. Okay, yep, never mind. That's all good. All right, so it exported a bunch of stuff. Let's see what it actually exported. Well, none of that is right. All right, so go back to Visual Studio for a second. What am I messing up here? So we have our total sprites. Oh, yeah. That's what it was talking about. I wasn't actually passing total sprites to the buffer or to the format command, and so it was just getting garbage. All right, so that's good. Just let that run through and go back into Sublime Text. Okay, that's a little bit better, except that now it's writing that out of order, which is probably just a copy paste mistake. String cat. Oh yeah, it is just a copy paste mistake. We can just do an fprintf here. We don't need to do the string cat there. All right, so that's that, and then we've got this. Stop the debugger. All right, so export the project again. Okay, so we've got our tiles, although it's still adding the comma. Oh, which, yeah, I know why it's doing that. It's because we're counting through all the files, and not all of the files are actually going to be exported because they're not all relevant to the project. So just do some cleanup here. Before we tile count buffer, string length of tile count buffer minus 2 equals comma, then string length of tile count buffer minus 2 equals 0. We'll just re-null terminate it so that we're not going to see that comma anymore. Assuming that I did my really fast math there. Yeah, okay, cool. So now we've got 2, 1, 1, 4. That's the number of sprites. And if you look at the sprites we're talking about, we have the blaster, which has 2, the bullet, which has 1, the flyby, which has 1, and the player, which has 4. So that's good. That's what you would expect. That's fine. So now we want the actual tile buffer, which is the actual tiles that need to be used. And then we have the X offset buffer. And then the Y offset buffer. And I get that this is kind of ugly, the way I'm doing this right now. I could probably clean this up a little bit. There's some other stuff we could do, like instead of using a buffer, we could, you know, save off the list of files we're actually going to process and reiterate through them over and over. I don't know. I mean, I'll clean this up another time. It's really, because this is a tool that we're working on and it's not going to be something that's critical, you know, unless we start seeing some sort of weird performance problem or memory problem or something crazy, which we probably won't, then, you know, it's not really imperative that this is the best thing we've ever written, just for the sake of keeping it simple and straightforward. At least I think it is. All right, so we've got that. So now what we want to do is we want to append the current tile to the tile buffer, right? So we want to put it in there, max buffer size, and then the source would be the temp format. I like how the autocomplete is showing up at the bottom of the screen. Sprint fs, temp formatting temp. Not the greatest name. So this will also be $hex, and then tile, current tile ++. And then we'll do the same thing here, basically, which is right. We'll add the comma. Oh, except we got to add the comma here, because otherwise it's not going to get added enough times. If j doesn't equal j, total sprites, that's 1. Right, we only need to do it for all but the last one. So that gives us our array of the tile indexes, and then we need to do our X and Y offsets, where previously we were just writing code to add them in. Let's see, so if, well, it doesn't matter if they're 0 or not, because they're always going to be necessary to be written. So we still need this, where we're calculating our X and Y value as we go. And let's see, so same, we have our other buffers here. So we have our X offset buffer, come on, let me do the same thing. So, I mean, the downside to doing it this way, where we're actually writing the value to the file like this, is that it's going to make the file pretty big. On the flip side, though, like I said, it'll let us see the values a little bit better, I think. We may change this again to write to a binary file. I realize I just put the same buffer in here. Let's fix that, and then this should be Y offset buffer. We may change this again to write to just a binary file so that we're not crowding up the output file we generate with a bunch of text representing the data, but I'm okay with it for now, just so we can examine it pretty easily. Alright, so that's that. And then we need to do the same thing for the Y. And the Y offset buffer. Right, and then once we're done with that, so this assumes well, actually, that'll work. So I was going to say this assumes that all of the tiles and offsets are in one big array, which at first I wasn't sure I'd be okay with, but because the way that we're doing this is, if you have right now you have the entities, right, which says, okay, this is 2 tiles, and then you're going to have your tile indexes, right, or indices, if you want to be all fancy about it. And then you have your X and your Y, right? And so you should be able to relatively quickly, it wouldn't be that much work to calculate the, I mean, I don't know. I didn't want to do that. Like, you can basically say, okay, well, the first one is 2, I don't know, maybe it'll be okay. The first one is 2 tiles, so you just add 2 to the index that you're going to start at. And basically you're summing up. I mean, addition isn't very expensive to do. It's not like we're going to be doing the multiplication. That would be, more expensive to do. So we're just adding up these indexes until we get, or the indices until we get to the entity we want. On the flip side, though, I guess we lose the ability to be quick about indexing into this. But I guess that's a good trade-off, because although we can index into this quickly if we just look up by the entity ID, then we'd have to look into separate buffers, and while we're for each entity, and then while we're potentially losing a little bit of a few cycles by summing as we go across this entity array, on the flip side, then going into here isn't such a big deal because we're just indexing into that. The only time we would run into a problem is if we had more than 255 items in these lists, which may happen. I don't know. We'll see. What we can do is we can put a little check in here, and that can be, a warning for us if we have to refactor this to make that work. I mean, at that point, I think we would end up having to need bank switching probably to make that happen. So assert current tile is less than or equal to 255. So if that's not true, it's gonna break the application on that point, and that'll be our warning. Because right now we're gonna just do 8-bit math to determine we're to do 8-bit math to determine the index into these other arrays that we're building. All right, so we've got the X, we've got the Y. Are we doing anything in this code that we need to carry over? Don't think so, other than this, which, if you remember from last time, I was saying technically is redundant, only because it shouldn't get past that point anyway based on the total sprite count, but it was just kind of a safeguard here, so that's fine. And we're adding the commas, and then I guess similarly here, what we want to do is this slightly ridiculous check for all these other buffers, right? So rewrite this code a million times. All right. Do that for the X offset buffer, the Y offset buffer, and then also the actual tile buffer. And then we want to, so that's going to be that buffer written. Probably want to do a whole new 2 new lines after that, and then we're going to have entity tiles, new line, and then same thing, we're going to write our byte, and then actually you can tidy this up a little bit by putting it all on a single line. Byte, and then that, and then tile buffer, and entity X offset, Y offset, okay. So we export that crazy thing, and what do we get? We get not enough new lines. Where did I, oh, yeah. I stripped them when I was combining the lines. What's that all about? I mean, the data looks actually pretty good, but the formatting of the data is wonky. I just did something stupid with the commas, I'm sure. Oh, wait a minute. Tile, yeah, so it's doing this for each one, shouldn't it be? Oh, no, because if we're doing this all in one array, it doesn't matter that we're reaching the end. We'll strip off the last one that we don't need. That's what it was. Okay, so yeah, much better. So that looks pretty reasonable. So for the blaster, it's tiles 59 and 5A with these offsets. And then for the flyby, it's just the 1 with no offsets. Okay, that's actually pretty good looking. And then let's take a look at the other files. There is this entities include, which has the indexes to the entities, which is, well, that's wrong because it's 0 index. So we, should I guess I'm going to offset everything by 1 byte just for the sake of not having to fudge anything on my code side of things. So that's a little annoying. So this should just be 0. And then we got to do that for the rest of the buffers. Okay. So go back to Sublime Text, and now everything is offset by 1, which is what I wanted. Okay, cool. So that is good. That is what I wanted it to be. And so now what we'll do is we'll include that file down here with the rest of the data that we have in here. So let's see. So now I gotta actually copy that over from the project file here. This is actually, okay. So that's that. It's the only thing we need to replace there. Now, obviously, it's not actually doing any of the drawing yet. All right, so how do we start this? So now that we have this crazy thing, well, let's first make sure that that builds. Okay, it does. Good. So let me think about this. We're populating the location in sprite mem based on the Y offset. And the first thing we would want to do is based on the entity type. Right? So we're going to base that on the entity type. We're going to index into the, where's that file? Into this. And the reason that it's offset by the 1 is because all of the entities that aren't no entity, which is index 0, start at 1. So let's see. So is this going to work? How do I can't see. This is the problem with spending so much time in the asset tool. I totally blanked on the syntax for the assembler. Let's see, where's the code where it's loading the palettes in? Because that's what we wanted to do. Same kind of thing. So palette with the X index. So, So I guess I want to push X and then transfer A to X. And then I want to load A with entities, comma X, right? let's see. So I've got the entity index now. Oh, well, actually, no. So this is the part that I was talking about before. So even though we can get this by just indexing in, we actually have to loop through and count. So we still want that to be an X, but instead of doing it this way, what we want to do is we want to, so if this is 1, I want to count this. No, I don't want to count that. I want to count just the 1 right before it. So I want to decrement X, and then clear carry, add count with carry. Wait a minute. I'm confusing myself here. I still need to do this decrement. I load the ND value into A, and then compare it. Let's see, branch if not equal to, this is going to be called something like find index. So let's see. So I actually don't want to load A with that. I want to add. All right. Struggling with the assembly here. Let me look up my my 6502 cheat sheet. So I can do constant. I can do an address. That's going to add it to the accumulator. And so I can do this. I can say add carry, clear carry, add carry, that, and then branch if not equal, because I want to branch if it's a non-zero value, which, okay, right. So if we do the case of what is the first entity, the blaster, we don't have to do anything. Do we? Because of this? My no entity type, my no entity is messing this all up. Or wait a minute, am I just being stupid here? Oh, okay. Yeah, I am being stupid, but not for the reason I thought I was being stupid. So what I actually only have to do, so I was adding the additional 0 to everything, but I really only need to add it to the tile count buffer. And the reason is because everything else can be just straight up indexed the way that we want it to be. This, because the entities are 1-based essentially, needs to have that additional 0 there. Everything else is fine. So let's regenerate that. So copy that back over. Not did it not actually copy it over? Export. Sure that that actually exports. Or did I copy in the wrong direction? It'll be nice to actually just run the executable straight up in this folder so I don't have to keep copying things back and forth. So let's go back to Sublime Text. Okay, there we go. All right, so for this, I'm going to this, I'm counting 0 because of the offset. There are no tiles. So that has, when we get out of there, basically we know what our index is now. So store A into temp, because we do need that. And Eventually we'll need x back because x is the index into the entity we're currently drawing. So let's see. So now that we have the number of tiles that we need to offset by, we just grab them and we count, right? So, all right, so y is currently being used for indexing into our sprite memory, and x is necessary to get our entities, so we're going to have to do some shuffling around. We've got our count. Well, actually, we don't maybe need to do anything because we can still do the decrement of temp without loading it into A or anything like that. We're going to need to increment x though. So let's see. So load x with 0. Well, one thing at a time. I'm jumping around here. So the first thing we need to do is actually load the y value into the sprite mem here, right? Because it's the 4 bytes, the y, the tile, the palette, and the x. So let's do that. So let's pull x off the stack, and then let's load that up. So what did that look like again? Oh, I also still need, I guess I still need to be able to do the x increment here. Well, I'm still getting ahead of myself. Let me take a look at this for a second here. Another good benefit of having source control is I can see changes when I need to reference back to these changes. So what was this doing? So it was storing sprite mem1. Okay. Right, it was loading A. Okay. So load A with entities. Oh, that's going to be a problem, that naming, because, well, it's case sensitive, so maybe it's not. It's potentially going to be confusing. Let me let me rename that just so that it's not as confusing or more confusing than it already maybe is. So let's, where is that label being written? Let's call that entity info. Or entity offset. Export the project. Copy our file back. Okay, so that's now called entity offset, which is fine. So 867. Colon expected. All right, sorry, let me focus on what's going on here. So I'm loading the offset into here, and we're just adding it to the accumulator. We actually need to load A with 0 because we want to make sure that it's zeroed out. So now we're incrementing A based on the offsets that are in this file, and then we're storing it into temp, and then we're getting X back because we want to start referencing values that are relevant to the entity. So not the type, we want the Y position. Right, and then we're going to store that into sprite mem Y. And this is going to need to be fixed also because of the offsets, which I'll get to in a second. So then, now that we have that, we want to increment Y. From a coding perspective, this is definitely more complex than the other approach. All right, so we've got our Y position. We're storing it in the sprite memory in the appropriate location. So the next thing we need to get is the tile information. So let's see. So then we want to push X again. And then where would that, so we would need an index count for, so we need another variable to hold our index position in these different tables. So we'll call this table offset. Oops. So what I really want to do is I want to store this into table offset because I want that to be zeroed out. I also want it to be 0, but that's a different story. So that's stored in there, and then we're going to increment Y, and then I need to get the tile that we're currently working on. So I want to load, I do want to push X again. I'll load X. And I'm sure that there's going to be a way to optimize this, but I just want to get it working and see where we're at once it's working. So we push the X, we load the X with table offset, we load A with what did I call it? Entity tiles X, and then we want to store that into sprite mem Y. And then right now we're not doing anything with the palette. So we can increment Y, and then we can load A with 0 and store A with sprite mem Y. Let's put some notations here. And I realize that it's more than just the tile and the palette, but that's all we're using it for right now. And then this is the X position, and for that we actually have to pull the X again, load X, no, load A, entity, tiles, X, no, a lot going on here, plus entity, X position X, and then store A into sprite mem, Y, and then we increment Y here, and I forgot an increment. And then we need to decrement temp, and then load a temp, and branch if not equal to continue tile load, right, which basically starts where? Store a temp pull X starts here. Is that right? Branch if not equal. I don't. Let me think about that. we actually want the 0 index, so I guess I want branch minus. So once we've processed 0, I think that's right. We'll see. This is gonna be a little messy, and it's gonna take some debugging to do. And PLX is already defined. I don't mean PLX. I meant, well, wait a minute. Did I mean PLX? Probably not. Push X, right? No. I have to transfer it and then push it? Right. I was making up my own instructions. Transfer X to A, push A. And then pull A, transfer A to X. Well, that stinks. And then same thing here. So pull A, transfer A to X. Transfer X to... Oh, wait a minute. I can't do that yet. Transfer X... Okay, I'm going to do over here. Transfer X to A, then push A. Come on, man. And then I load A, and then I transfer A to X. And then I load A 0. And then I'm counting. And I store it, and then I get back my X so I can look up the Y. And then I do the tile math. I do the palette, which is 0. And do my X work here. And then I decrement temp. And then I check to see what the value is. And if it's minus, we go back to the continue. And then once we're done, I think. Now I know I'm not handling I'm not handling the math part. All right, what's the problem here? 877. Syntax error. Unexpected trailing garbage character, colon, expected. Is there something I'm missing? $877. Add carry entity offset X. Does it not know what entity offset is? No. It's not that, right? No. 8. Oh, it is. 882. Oh! Well, that's weird. Branch equal. What? Branch not equal. Oh, yeah, you got to give it a branch. Where it's branching to. Find index. Type is undefined. 869. Is it lowercase t? I guess it is. Okay. So this is likely going to be completely broken, as it always is with every big change we make. But let's see. If we get, okay, well, we've got, whoa, are we, is it that bad already? Whoa, okay, something is really wrong, because it's counting 11,000 cycles, which is why we're getting that weird graphical issue. So yeah, let's debug this, because something is, it shouldn't be anywhere near that. It's obviously something else got messed up, and probably one of our loops is broken, and that's why it's taking so many. Let's see, so 7F E. Add right breakpoint. Okay. So we're loading Y with 0. We're storing. Okay, we're over here. So now we're getting sprite mem set up. Okay. And now we're transferring X to A because X has our current index into the sprite. And then we're pushing A onto the stack. Oh, we can't do that anyway. Well, no, that's okay. No, it's not. It's not. Okay. I missed a whole big piece of this pie, which is that we are not we're not doing this part anymore where we actually increment the X index and then checking to see if we've reached the total entities, which, you know, that might be a problem. So once we're done with that, we want to transfer X to A, right? We want to clear the carry. We want to add size of entity, and then we want to transfer A to X and compare X to total entities, right? Because we got to make sure that we're actually like indexing into more than just the first entity. So done sprite is that. Otherwise, we're going to jump to the beginning here for draw entities, and we're going to do it again for the next entity. Okay. So that explains why that was so screwed up. I keep hitting, I guess, the wrong... Let's disable this breakpoint. Run. Let's just... Now it's not running at all. So our Lua is not getting This is the live stream of how to break your code. Whoa. Okay, so not excuse me. Not what I was expecting to see. Probably not good. Looks pretty cool though. So let's re-enable that breakpoint. And let's reset the game. Run. Okay. So what is this that I'm looking at? This is not... Okay. So title screen, we hit start and we go into our first loop of the VBlank, the NMI. And we're setting up the sprite mem with the 0 to 100 for the DMA, and then we're storing A with the index of load A2. Oh yeah, right. We're still not there yet. Okay, so now we're doing the transfer and the push, and then we're loading 18, right, so we're loading the entity type, which is 0. Transfer A to X, load A0. I guess what we need to do, excuse me, something's in my throat here. We probably need to do something like this. We'll skip the sprite if the type is 0, because there's nothing to do, right? So Transfer x to a, clear the carry, add the size of, transfer back to x, compare it, branch. Okay, so that's that. Let's run again. All right, so it is going to be 0, so we're going to step over and we're going to branch because there's no entity there or set. Oh, so in this case, there's actually no entity happening at all. So I want to set a breakpoint here because we're not at a point where any of the entity stuff is loaded, it looks like. Or not. Well, that's no. Okay. So okay. Yeah. Wait. Did I set the breakpoint in the right spot? I did. Run. What? Oh, that's fun. I am very confused by what I'm seeing here. Run. Okay. So let's see. Let's take a look at this for a second. We're loading the entity type into A. But the first entity should be the player. So that, I mean, that should be, that should already be set up. Let's see, entities. Where is my entity? Oh, it's over here. I'm just gonna do some rearranging here so I can, oh, I gotta copy all of this. I want to rearrange this so that this is the beginning of the memory, so it's just easier to find. Where did all the debugging windows go? Okay, run. Okay, max editor. All right, so we're at the beginning. Everything is zeroed out, which is fine. Right, it shouldn't matter because, okay, we hit a breakpoint. So the NMI happened, the entities are, oh no, they're not, okay. They're not initialized? What? Step over. Transfer X to A, okay. Load A for X. Oh, wait a minute. Did I... This is the type. That's so bizarre. So it's calling this before the entities are ready. Why is this FFFF? Oh, because it's setting sprite 1 off screen when you load the game. It's clearing the entities there. For the X and Y. It only did that once? Total entities. Oh, that shouldn't just be total entities. That should be, the value should be total entities. So that was never clearing correctly in the first place. Total entities. No, okay. That is right. Because total entities is actually doing the calculation. So that should be clearing. Let me go back and restart this again. So that's completely blanked out now. And then if you run it again, only the first. Whoa. Why are the entities not cleared out the right way? Is bizarre. Oh, is it processing game logic on them? It's possible, I guess, that it's processing game logic on them based on... Okay, so this is, it's loading the initial state of the game for the player, right? It's creating the player type and changing the game state, and that was working. But that's not what it's storing there. In fact, I do not know what those values are. And then it never comes back to this point again. I guess it's getting stuck. Oh, well, right now it's just the title screen. Oh, that would, yes, that would explain why those values don't have what we want. But that's still, see, it's still wrong here. Right, that should be initialized at this point with the location of the player. Still thinking something is wrong in terms of the what is it writing to over there? That's bizarre. I mean, if anything, it should be writing it over here because I moved all of that. Okay, something is wrong. So sprite mem. Oh, okay, it's writing the sprite mem at. No, but that's not even at 200. Sprite mem at 200 is here. What is it doing? That is. Kevin, the stack is the least of my concerns right now. Let me do this. Let me set a breakpoint here at, or let me write to a location that's going to cause a breakpoint here. And reload the ROM. And run this and keep running it. And so when we go to load the new game state, we should hit a breakpoint again, and we did. And let's look at the memory here we should be initializing the first entity. Step over. $56. What the hell? Load AO2. What is going on here? Is this the problem? No, that's just text. What am I doing wrong here? So you have this entities inc, and that shouldn't matter. And then we have that entities. We have our clear of the entities. Something doesn't make sense to me. Because the entities are now defined here, right? Right at the top of my 0 page. So, and I mean, these are constants assembled in. So that should be set when the new, wow, what is going on? Is this not rebuilding or something? Breakpoints, hit start, goes to that breakpoint, which is the first one where we're loading. Why is it storing, what's it storing at 56? So 7FE. Oh, this is already, is this not what I think it is? That's not what I think it is. So what is that breakpoint? Is this my... Is that my NMI already happening? I guess it is. But load Y, 56, 0, load A. No, but this, yeah, this is all... Why is any of this happening right now? Is it just because I'm so weirded out by this right now? So I should be getting my 7FE for when we initialize the player. Store A, yeah, okay, so load A. What is this that I'm looking at here? This is my NMI code. Is this because game state is changing before we're ready for it? It shouldn't be. Why is this getting called before my title screen code or my new game state code is being... Oh, wait a minute. No, okay, it's doing a v-blank, and then it... Oh, I guess it would make sense that it's calling the NMI, although it's weird that that... Did I forget to... process gameplay state. If title screen branch not equal, compare game state to title screen branch if not equal to the process gameplay state. Oh, I guess that's not technically right. Realistically, it should be doing... It shouldn't be doing this until... It shouldn't be branching until... we're playing the game. Right? Because that... there are some intermediate states that we don't want it to do this stuff for. So I know I need syntax highlighting. I need a lot of things right now. Potentially a stiff drink after this has gone so poorly. Alright, so we'll run that. That's the initialization. This is more initialization. There's our title screen. I want my Lua code back. Okay, and then I hit start and okay. Yes, so now we've initialized, or hopefully we've initialized our memory. That looks much better. Although the player state is still wrong. What's the order? So it's the X position. Oh no, the type is not that. Type is 4. Okay. Okay, but that's good because now at least the memory is set up right. Although this memory has junk in it, which is strange. Shouldn't. We have a lot of entities in here. It should have actual, I mean, it should just have zeros essentially. But okay, sure. Where's my debugger? So that's okay. Now at least the player is initialized as expected. So now we're going through the process of processing the entities, and the player type is not 0 anymore, so that's a good start. We're transferring A to X because that's our offset, and then we're loading A with 0 because we're going to start counting our index offset. So 1, 2, 3, 4. So we're going to start by counting 1, 2, 3, 4, 0. Okay, so 4, right? So we should end up with 4 by the time we're done here. So decrement X. Well, that didn't actually, oh, it didn't actually do it yet. Okay, that's fine. So add with carry. So we get our value of 1, which would be this one, which is fine. I guess I should just keep it on this file, and we just keep looping through 2, 4, 0 gets added, and then we're done there. Oh, it's not done there? Well, because my decrement is stupid in a bad location. What do I want to call this? Or where did I put this? Scope. I only have a few scopes in here, so this decrement, probably want to decrement it here, and then think about this for a second before I start going crazy and making dumb mistakes. No, actually, maybe that was okay. Well, no, because, oh yeah, branch if not equal isn't going to work if it's compare x to 0. Okay, right. I'm thinking decrementing a, and then you just do branch not equals, but that doesn't work that way with x. All right, let's try that again. Title screen, hit start, step over, we do our jump. Now we're going to run to the point where we're ready to start drawing the entities. Okay, so again, we're doing entity 4, which is the player. So now we're counting up our tiles, which we should get 4. And then finally we compare x to 0 and we branch if not equal, otherwise. Okay, so now we're storing a into temp. We're pulling the x value off the stack, we're transferring it to x. Now we're loading the y position and storing it. We're incrementing y. Now we're saving off the x in the stack again. We're loading x with some value that, let's see, so the table offset, we're loading it with table offset. Is that what we're doing? No. Why not? We should have stored it. We didn't store it. Oh, we stored it in temp. We stored it in temp. The table, okay. So this isn't really table offset so much as this is wow, I've just made a mess of this. Okay. So conceptually this is all pretty straightforward, but doing this in assembly just is somewhat of a cluster right now. So the problem is I'm loading this value based on the table offset, but table offset is the totally wrong thing to be looking at, right? Table offset is zero all the time. We stored the offset here in temp. So what we really want to do is we want to store that there, or load that into X, and then load that into, and then load the tile from there and store it into sprite mem in that position. And then we pull and transfer, and that would be fine. And then we're decrementing temp. Actually, what we want to do oh boy. Okay. All right, I think I realized what I've messed up here. So the problem is that we're calculating the offset into here, which is fine. We're storing it into the wrong place, or into a place that we weren't using it, and then we need to increment that based on the number of tiles, which is in here. We're not doing that because this is a little nuts. All right. So that's entity offset. The first thing I guess I need to do is I need to load A with the entity offset X before I decrement X, because I want to get the actual number of tiles. I want to store table offset with the number of tiles that we actually have to count up to. Or down from, realistically. And then we want to count, we need to know, okay, and then also how many indexes do we need to go in to our array here to find our starting position, right? So, and that is this entity tiles with the X, and temp is going to be, so temp is going to be our offset in, and then we're going to decrement table offset until that's 0, not temp. We want to increment temp because that's going to increase our position in the tile. So we want to increase that. We want to decrement table offset. We want to load a table offset. And if it's 0, then if it's minus, then we're gonna jump. We'll wait. No, branch. Branch equal to continue load, branch positive, continue load, right? So if it's greater than or equal to, it's got a branch. Otherwise, it's done with loading that. What is your problem, assembler 874? Yeah, no, that's not right at all. Okay. Okay. We haven't had problems like this since the beginning of the stream, and I really didn't know what I was doing with the NES. Alright, so that's our first setting of that, where we were initializing the memory for the player. So we're going to step over, we're going to load. We know the type is 4, that's what it was set to. We know that it's not 0, so we're not going to jump there. Transferring A to X because we needed to have the offset there. We're going to load A. Okay, so that's got the 4 that we need. We're good. We're storing that into memory so we can do our countdown. Now we're zeroing A. We're doing the add of the offset. We should end up with 4 when we're done with this loop. Okay, now we're at the last one, so that's good. So now, all right, so now we're storing A into that location, which has the value 0. What is that I'm storing into A? Temp. Why? Why does that have 0? Branch not equal. It should. Oh, it has 4. Okay. That's fine. That's good. Step over. Good. Pull A, transfer to X. Load the Y position. Good. Increment. Now we're going to push X back onto the stack. We're going to load X with temp, which is our index into the entity tiles, and we're going to then index into our tile info and load the tile with 5D, which looks, let's see, so 1, 2, 3, 4, that could be right. That looks right, potentially. So, okay, and then we're storing that into the sprite mem and incrementing y. Then we're dealing with the palette by just setting it to 0. And then we're getting our x off the stack and transferring it back into x and loading the x position value into our sprite mem and incrementing y. And then we are incrementing our temp and decrementing our table offset. And then we are comparing that. We're checking to see if that's 0. And if it's not, it is positive though, so we're going to keep going. So this is going to be wrong technically because it's still going to load tiles over the other tiles, but it's at least better because it's actually mostly working the way. All right, so let's see what happens. Okay, so we got this one. So this is similar to what was happening before, right? Where it was displaying, except it's not hitting any breakpoint now. It's just in a loop. So previously it was showing the sprites stacked over, and that's fine. Step out. What is it? Is it just totally screwed right now? Looks like it. So it increments one frame and then dies. So part of this is that it seems like it's not initializing the memory properly for some reason, which is weird because that was never a problem before, and that's still very odd. I guess that's NMI code that's still executing, but why? When the game first starts up, clears out all my memory. It goes through and it clears the entities by setting the entity. Oh, okay. Well, I mean, that's not technically wrong either. It's setting the entity type to 0, and then it's changing the X and Y position to be FF, so the sprites don't appear on screen. Why isn't that working? Like, there's something really bizarre happening that I can't quite put my finger on. So like this is all working right, but this memory is not initialized properly, and it was before. And if you go to, if you reset the game with the breakpoint set where it zeroes out all the memory, this is the portion here where it was clearing all the memory. So that's fine because, you know, we expect that to be all zeros and getting zeroed out. Although that's still not. Oh, right, yeah, and that's fine too because that's getting set for the sprite memory at 200 where we're going to have our sprites. So this memory here is where we're going to have our entities. And so now at this point it should be, let's see, where is that code? It's right, load 0. our increment. We have branch if not equal, load A21, H swap, H, load X00, load XFF. So this is our clear entities here. So let's breakpoint on that. So store A, which is 0, into position 0. So that actually looks right. All right, no, A has the A has the FF in there. So it should be FF, FF, 0, right, where the X and Y position are F'd out. And the type is 0, because that means it's no entity. And then do it again. Wait, whoa, what? Y, load A, FF, transfer X to A. Oh. I goofed that up by trying to be clever. So that is why it looks like that's not working as expected. So let's see. So that's the memory clearing. So A is, yes, that's good. And then and X is 0. It's adding 6. Right, so that's our offset, and then we're gonna do that again. So let's take a look at the hex editor. Okay, that's looking more like what it should have looked like in the first place. We can remove that breakpoint. Okay, so that's looking reasonable now. This is for the palette stuff. We don't need that anymore. Okay. That's looking more like what it's supposed to look like without some crazy values in it. So now when we go to process, what is this? I don't know. That was not what I was looking for. Okay, when we go to process our sprites, the type is 4 for the player. We get our offsets. Right, so that's good. And then, all right, we're storing 4 into that location. We're pulling A to get the X index. We're storing that. That looks good so far. We're getting the tile 5D, that's good. We're incrementing Y, loading A. Okay, getting our index again. Okay, that's right, yeah. And then we're incrementing temp and, wait, wrong place. Decrementing table offset, and then we're loading table offset into that, and then we're going to branch as long as it's positive. And we're just going to keep doing that till we essentially get to 0. Question is, what will happen as this runs? Is it still at a breakpoint? Oh boy. And then it's funny how that isn't getting reinitialized properly for some reason. I don't know if that's a weird bug in the emulator or what, but that wasn't happening before. So this is all pretty decent here. Branch if equal, what is this? Continue. Oh, if it's, yeah, if it's 0, right, because we want to make sure, okay. Right, because it's got to be negative before we, maybe that's the problem. Maybe that condition is wrong. Oh, and you know, now that I think about it, where is this? Continue tile load goes back up to here. That's, no, that's okay. I ran through that too quickly. Let's, all right. This is the title screen transition. We're back here. Let's look carefully at the way that this is working. So our 200 range here is cleared out. We don't have anything that's good because that's where our sprites are going to live as we populate them. So what do we want to do? Let's see. I'm going to, where's 200? Where'd you go? Just want to put the cursor right there. Okay. So we're going to store, once we get our offsets all dealt with, we're going to start storing into 200. Yeah, so that is looking reasonable. And then we increment Y again. We increment temp, decrement table offset. We load the table offset. It's good. So now, where did we jump to? We jumped to, we should be now looking at, yeah, so X is fine, right? X is fine because it should be 0. Right now we're basically clobbering the first sprite we wrote, but that's okay. We'll deal with the offsets once we get this all sorted out. The tile is right because it should just be one more in 5D and 5E, so that's good. Okay, so now we've got our X position written. So that's our second tile, our second sprite. That's our, now we're writing our third sprite. And now we're writing our fourth sprite. And this should be the last one. So we're incrementing and decrementing. Oh, but it's 0. So I just messed up my logic here. Is that what you're saying? I guess so. Yeah, yeah. Too many different offset types. It's my own fault, obviously, but all right, let's go back to debugger. That's the hex editor. Where's the debugger? Run that. That's the title screen. Transition, step over. So let's look at our memory again and let's check it out once we've written 4 sprites out here correctly. So I'm just watching the memory here as I step over to see the bytes being set. Okay, so at this point, now we should not branch. Whoa, it did branch. 0 considered positive? I guess it is. Damn it. Can't catch a break here. Branch if equal to skip sprite. Otherwise, it'll, well, I guess we just jump to continue tile load. Run. Transition, sprite, drawing. Where's my hex editor? Okay. Now the irony of all of this is probably going to be that this is less efficient than the way we were doing it before. But we won't know until we try. So, okay, so now we're at the point where it should jump to, yeah, okay, good. So now it will increment by the size of the entity. It's going to compare it to see if we're at the end, and we're not. So we're going to jump back to the top of our loop. And we're going to transfer X to A. We're going to push it back onto the stack, and we're going to now start looking at. Oh, so that's a problem. All right, so the other thing that was blowing out our stack here was that we put a check to see if the entity type was 0, but we had just pushed that on. So what we need to do is we need to do this. We need to say branch if not equal to continue with sprite. Let's call it continue with sprite, and this will jump to skip sprite, but we need to pull A, or yeah, we need to pull that off the stack, because otherwise we're going to fill up the stack real quick. And yeah, we do need a colon there. What did I call it? Sprite skip? Skip sprite, all caps. I guess I should be more consistent about that. At least I'm being consistently consistent about how I label my labels. All right. The title screen, transition, and let's watch some memory again. Second sprite, third sprite, fourth sprite. Okay, so now we're at the end. Branch if equal, transfer X to A, add with carry, transfer A to X, compared. We're jumping. All right, back here. Branch if not equal. All right, we're pulling it off the stack. We're jumping, transfer X to A, clear carry, add. Okay, good. So that looks like it should be working now. Oh, I'm still still doing this. Let's turn that off. Okay, that's a little bit better. That's even better. That's even more better. Yes, I said even more better. All right. So based on the way this is behaving, this is definitely not as good. Even just this, without incrementing by the offsets for the X and Y, this is definitely not as efficient. I mean, just this one sprite is causing us problems, but as we add more, you can see the cycle count has gone well over the 2200 mark that we were shooting for. So now the question becomes, is there some way that we can make this more efficient, or do we go back to what we were doing before? And I guess the question then becomes, like, where are we spending all of our cycles? And I assume that part of the problem is the fact that we're doing some of these, well, I guess the push and the, well, I shouldn't say that. The push and the pull maybe isn't super expensive, but for every time we do it, we also have to do the transfer. So that's 2 cycles. We have to push A. Let's see. How many? Have a length of 1 byte and require machine cycles as indicated. So push A has 3 cycles. That has pull has 4 cycles. So that's a lot of stuff we're not doing in the other approach at all. So could we do something to mitigate that, where we're not messing with X anymore? I mean, we could, I don't know. Because the problem is that we need to index into these, entity tiles and entity offset. And unless there is something else we can do, let me think about this. So in order to index into this memory location, I mean, the other thing we could do is we could just use, can you just use an address? Like wow, not that. I'm wondering if we can just do so we can do a store from a memory address. We can, I'm sure, do a load from just a memory address. And so if we made the memory address, well, it wouldn't be 0 page. So we'd need 2 bytes for it. So instead of using the X offset, if we were to take the address of the entity offset and store it into a variable, and then increment that, that would potentially be, let me think about that. So the benefit of doing something like that is we're incrementing the variable, right? We're saying, okay, this variable, well, thanks for zooming. I didn't want you to do that, but that's great. This variable is pointing to this location in memory, and we're just kind of zipping along in memory here, right? And so if we wanted to do if we wanted to handle the offsets, we could actually just keep incrementing that pointer by the amount that we find here initially, right? So let's say we say, okay, the tile value is starting at entity tiles, and then we just keep incrementing it by that. That would work. We still have to keep track of how many sprites we've actually created based on this number. So that would still be something we decrement and then check the value of. That seems like that might be more efficient, because then the only thing we're doing is we're just incrementing that pointer and decrementing. We're not doing an increment and a decrement, and we don't need to mess with X, I don't think. So let's try it that way. So sprite mem would be our sort of example here of how we're doing that. Whoa, whoa. Don't put the pen on the tablet. Where's sprite mem? There it is. So let's call this tile mem. And we also need 2 bytes for that. 7ff fe. Right. So we want to load A with, what is the syntax? Is it that for the, I think that's right. I don't remember now for which one it is. CA65 low order. Is that right? No, you can do, let's see. Where's the, you can do .low bytes, but there's, this is equivalent of byte with the operator, so that's low order. So that's 3F. Let's see, looking at sprite mem, yeah, so I want to load that there, and then we'll store that into tile mem, and then I want to load that and store that into tile mem +1. Let's just, suspicious address expression. You're suspicious. Why don't you like that? You can't do that for a table item 0. Define table item 0. Is it? Do you need to do this? I didn't think so. Not using this anywhere else. C65 load label low order byte. I know I've done this before, but I don't remember. Do I just, is it just this? You say entity offset and entity offset plus No, that wouldn't work. It's just low byte like that. I know I've seen the syntax somewhere for this. Where's low byte like that? It's like that. Pseudo functions low byte. No. There's high byte like that. Well, isn't that just what I was looking at? L-O-B-Y-T-E. Do I need, is it like a dot or something? 864, suspicious. I don't know why. It's very odd and unhelpful. Suspicious address expense. Suspicious. What doesn't? It seems like the suspicious warning should be implicitly silenced. So, this is line buff. With a non-zero direct page base. What don't you like? Not really super helpful. Let's see what the let's see what this looks like here. All right, so entity offset, low byte, load A 44, so 8544, which is the address. So that's actually okay. I'm not sure why it thinks that's no good. It's suspicious that that's suspicious. Hex editor. So where's that in memory? It's going to be after the entity. But before this thing, where did it store that? Did it store that? Stored it in store A in 58. Or it said it did, but it did not. Load A with 44, and then, oh, wait a minute. Oh, are you kidding me right now? Store A, tile mem, debugger. Wait a minute. It's storing it into this 58 and 59. Yeah, okay, that's getting tired, and I'm second guessing myself here. So 58 and 59 would be over here. So it doesn't appear to be actually writing anything. 0, 0. Oh, because it's writing the it's loading the address, which is not what I want. Okay, so that's, I guess, what the problem is. It's loading the address of the low byte into A, or the value at the address of the low byte, which is not what I wanted. I wanted the actual value to be, can you just prefix it like that. That actually works. Okay. Hey, like I said in the very first recording of this, I am no expert when it comes to the NES, and I think this episode is proving that. And it is as much a learning experience for me as it is for you, hopefully. Okay. So let's see if we got this cleared up now. So that's okay. So now it's loading 44 into A and storing it into 58. Yeah, that's much better. Okay, so that was the problem. It was trying to load the value of the address, which is why that suspicious address thing went away. Because I wanted the value of the address of entity offset, not to load the data from the address that was the low byte of entity offset. Right? In one case, I'm saying I just want the value of that address as low byte. And in the other, I'm saying take the address of entity offset, get the low byte, and then load whatever memory address that is to A, which is kind of a weird thing. It's not something that you would want to do. Okay, so tilemem now has the address we want. So technically, that worked. So now, so we could actually potentially pre-compute this offset if we wanted to in the tool. That might actually be a useful thing, so that we just index into it and say, here's our offset, and bam, we're good to go. But for now, we're still going to count it. And then instead of messing with the X value to get our tile, what we're going to do is we're going to say, what did I call this? Tilemem. So load A with tilemem, and then we're going to increment tilemem because we're done with that one. So we don't need to, we actually don't care about temp at all anymore, right? Because what we need to do is just, excuse me, we need to decrement the table offset. So now we don't have to do that pull and transfer. So we're not touching X at all in here anymore. So that's good. So maybe that'll help a little bit. Let's reload our Lua stuff here so we can see what our code is looking like. So this is it before. Turn off this breakpoint. This is it before we made that change. So it's about 1464. If we reload the ROM. All right, so we shaved about 60 cycles off doing that. We also messed up the tiles somehow. It's still pretty bad though. All right, so what's up with tilemem? Oh, okay. So now the issue is that we're not starting in the right index. So tilemem, we need to increment tilemem by the amount we've counted up, right? So we've got that here. Transfer A to X. We're going to load yeah, I guess we would just load A with. This won't work if the, well, we know that that won't work if it's more than 255 anyway, so let's just go with that. So we want to load the low byte of tilemem, right? And then we want to clear carry and add carry. Oh, actually, no, I don't even need to do that. We just do clear carry, add carry, the low byte of tilemem, and then store A into tilemem. And that will give us our offset tilemem, again, assuming we're only doing 255 tiles right now, which is a kind of a big if, but so that should offset. And what did I break it again? Yeah, so, yep, I broke it again. So, oh, right, because because I'm doing this between the compare. Yeah, good work. This is still wrong. It's still slow. So let's see why that is. Should be getting Am I doing it every single time like a complete idiot? Sure am. I don't need to do it every time. Just need to do it at the end. So at the end, A has the value that we want. We want to clear the carry, add the carry, the low byte of tilemem, and then store that into tilemem. Wow. Okay, it's a little bit better. The offsets are wrong, but at least it's working. You know, at least in theory. So what are we off by? It's the flyby, right? So we're off by 1. Let's see. So that would be because if we have 4, take this and we add 4. Yeah, so it would need to be is that right? 0, 1, 2, 3. No, that's technically right. Is it just not? Is this? Unless the tilemem location is. No, I mean it would be right there, so that would be 0, then 1, then 2, then 3. A should have been 4. Oops. What are you doing? Yeah, that doesn't work that way, right? You can't just increment A that way. Wow. Well, I would say that I think this is probably, the more we work on this, the more this seems to kind of just be a can of worms that is getting worse and worse. I really want to know why that offset is wrong. Doesn't make a whole lot of sense, other than just more random nonsense that I'm messing up. Okay, so that's the transition here at this point. So let's take a look. So we're setting up tile mem and we're loading the type. And then at this point, why is it already a 2 if the type is 4? Store A, load A, actually don't need to be doing this every time, do we? No, because that index should be fine coming into this. So why was I doing that? I don't know, that might be a holdover. Load A with the type, branch if not equal to continue, otherwise, so then we don't actually need to do that. Is that what you're telling me? Continue with sprite. Here we do need to do the transfer of the A to, oh, that's why? Okay, we did need to do that because eventually we clobber it. So transfer A to X, which has our value, which would be in this case, if we look it up, B1, right? So we're loading that value into entity offs, load A entity offset. Sorry. So, right. So it was 4 for player, so it's loading it into A. And then storing that into table offset, and then loading 0. Right, okay, right. Because it needs to know that how many sprites we're dealing with, right? Right. So that's table offset. So then we're loading 0 into A. We're decrementing X because now we're counting up the indexes that are here. So that should go from 4 to 3 is what it should be doing the first time around. So that's our transition. Okay, so if we step over here and we load we're doing the initialization. I should probably change that to a little bit further down, but anyway. transfer X to A, push, load A with the entity type, which is 4, transfer A to X, load A with the number of tiles, which happens to be 4, which is fine. I'm going to store that into table offset, and then we make A 0, and then we decrement right X, which is 3. That's good. We add A with that value. We compare X to 0. We keep doing that until we get a value for A. That is the number of things we need to index into the array. And then we add the low, oh, is it adding? Add carry. What? Oh, okay, we're still in the loop. Okay. I was comparing it to a different line than what I thought it was. Okay, so now it's adding the 58 to it. That's our offset into, so it's 4 bytes that we need to index in for example, this, right? So the tile memory is here. We need to go in 4 bytes. So that gives us 5C. And then we store that. So let's take a look. At the hex editor. So step over, and so now it's 855C. If we look at, well, if we just go to 855C, which is our ROM, 855C, let's see, 85C would be, let's see, FEDC, so it would be 8. Oh, I'm 1 row too high. So 0D, which is what I expected it to be. Or 0D? 5D? No, it's 0D. Yikes. No, that's why, because I'm doing it into the entity tiles instead of, right, okay. Well, that also explains some of the strangeness there. So it was indexing into the offset, not the tile information, which is wrong. Okay. I'll keep the breakpoint on because I want to make sure now that I'm seeing something that looks reasonable before we wrap for the evening. So it wrote what? So it did it already, right? It was load A5D. Okay, so that is actually maybe right now, finally? No. It's writing 5D, but that's not what is being displayed. Why? Just to taunt me? take a look. So in 200, I guess this is being initialized too quickly here. Let's see what it's actually writing into sprite mem at 200, because it should be 5D at 5E, 5F, based on what I'm seeing here. 5C. Where load A, the address of 58. Which is 5D. Oh, why am I incrementing? That was incrementing it because I thought it was broken, but now it's more broken? What? What is going on tonight? This is the wrong part. Oh, what? Come on, show me the sprite mem. Getting set. 5C. So that's... So it's supposed to do that in order to, right, continue on. Is this incrementing? This is incrementing the address of Tom. Yeah. So that was okay. Wow, I'm just... See, if this had been just, you know, plain old code, this wouldn't be so difficult. But because it's assembly, and I'm learning the system, this is driving me bananas. All right, so the portion where it's actually loading the tile, it's loading the address. Well, that hasn't been initialized yet, so... Okay. So now we're at the point where it would be loading the tile. So the first tile that it's showing a value for is 43, which is off by 1 byte, right? Because it should actually be, or it's off, period. It should be 59. Should be 59. So if I were to cheat here and say this is actually 44, and go to the debugger and look at the debugger, .44. It's still saying 44. Why is that? Is there something... Is there something that I am not... Well, obviously there's something I'm not doing right, but what the hell is it? That's the controller code. I don't want to look at that right now. So this part is right. Like it's writing the address. Why is it not? Load A, the address of 58, which is 43, which is... That's not what I want to do. What I want to do is I want to load the address of what's in here. And I thought, I guess that's not working. I thought you could do that. But I guess there... Well, let's do this. Is there a way to just do it like this? Yeah, so you've got to use an index. Like when I do this, I'm saying get an well, but I'm doing it with the X index, right? Well, what about the palette? The palette is... Isn't it... How is it loading that? Where is the... It's just palette. Oh, it's still using the X offset. So there isn't seemingly a way to do this without using X. So that was kind of a waste, other than no, that was just kind of a waste. It was not the right way to do that. I'm going to call it an end here. We've been going for almost 3 hours, and right now where we're at is that this is obviously not as fast as the way it was working before. And I guess that is going to just have to be the way it is right now. I mean, we can... The good news is, you know, it's not like totally messed up where we can't move forward with this, right? Because like we were talking about before, if this is really that bad, I can always revert it, right? So go back to here for a second and show me my modified files, please. Thanks. So if we look at it here, maybe. What tool is it trying to use? I don't know. I don't know what it's trying to show differences in. But anyway, it's got all the differences, all the changes that we've made here, where we've added some, you know, code to handle the drawing of the tiles. So at this point, I just need to figure out if there's a better strategy for handling this data, or if it's going to end up being like I said initially, where the process of actually figuring out how to index into these tiles is going to end up being way less efficient than just writing code to do it, which is part of the reason I took the other approach. But then, like I said, I was thinking about it in the over the weekend, and it just occurred to me that it might be potentially more scalable or easier to deal with if we loaded the tiles this way, but it's certainly not easier. It's definitely seeming like it's not as efficient to do this. So, I mean, I'm happy to say that, you know, maybe we just go back to the other way and we deal with the out of range problems. Because, yeah, I mean, even with it just running, and it wasn't even running properly, because it still wasn't dealing with the X and Y offset. I mean, we go back to the Lewis script. It was definitely running slower than before, to the point where now with all the entities loaded up, the game doesn't even run properly because we're exceeding the cycles we have available for the NMI. So that was an extremely frustrating stream, but you know, that's how it goes sometimes. You're working on something new and you're testing a theory out. You end up wasting some time trying to see if you can make it work, and I'm not ready to 100% give up on it yet, but I have a feeling that it's probably not going to work just because of the amount of manipulating that has to go on. The only thing I can think of that might help us is we could build, like I was saying, we could build the offset pretty easily into the entity tool, where we're adding the offset in immediately in a separate buffer. So we have we have our entity offset, which is that's kind of a misnomer. It's really the sprite count. But then we also could actually have something called entity offset, which does this calculation for us, so that we just know what to start out with for table offset, right? Because right now we're calculating that. So if we pre-calculated that and then got that to start off with, I mean, that might help us a little bit, because you know, we're wasting cycles recalculating that every time. Damn it, now I want to try that before we end. No, we'll save that to next time. I know it's going to help things, but I don't really know that it's going to help things enough to save this, right? Because it's going to save us not having to do the looping and the adding of the offset. We just get the offset and add it to the where would we would add it to temp, essentially, because temp is what needs that for temp is what needs that in order to. So the table offset has the sprite count, the temp has the these names are not helping things either between how long we've been doing this. So my variable names are a little confusing. That probably would be helpful to clear those up. But this is how many sprites we have to render. This is how many. This is our index into the tile buffer, tile array. And so if we pre-calculated that, we wouldn't have to do this find index loop. We could just get it out of an entity array here. And then, so that would be that would be substantially faster over the long run, especially because we're not recalculating this every time, which is totally inefficient. But again, I still don't know if that's going to be enough to save it. So I think that's enough for now. Anybody have any questions, comments, words of encouragement? I'm losing my voice here. Well, with that, I'm going to wrap it up, and I'll see you on Thursday at 9 Eastern. Hopefully it will be a less painful stream. We will get some more accomplished than this. Although, I mean, we did a lot. It's just, it was sort of complex and dealing with something hadn't done before. So, NES Homebrew, thank you. yeah, so I'll see you next time. See you Thursday, 9 p.m., same place. You can reach me on Twitter at Clairvis. The recordings will be posted as they always are. You can comment on that and come to the Nintendo Age Discord, where there are a bunch of people who have already done this and suffered through this and know that this is probably a waste of time, potentially, maybe, because they've already written games. But, you know, certainly learning a lot, and I will see you next time.